unit, we cover two main types of functions. The first type of function, I had my booklet here, oh yeah, here, is quadratics, and the other one is linear functions. Linear you've studied in IAPR, but now we can use our calculator. So finding x-intercepts, y-intercepts, all those things, calculator, okay? So you won't really have to do rely on algebra to figure that out, because the functions we study are quite frankly sometimes scary looking, but the calculator makes it a breeze still, okay? So here you go. Let's get everything going here. Okay, quadratic functions. A linear function has the equation y is equal to ax plus b, where a is the, we call it the leading, oh, I have to redo this. It's a bit long of a longer word. Two words actually. Leading coefficient. Leading coefficient is like a number that is at the in front of the variable, to be precise. And the constant b is the, what would that be? Do you remember that number that follows something with x? What is that on the graph? The y-intercept. Do you remember that? Y-intercept. And you're probably thinking, Mr. Erickson, I never saw y equals ax plus b. What did you see? The a was actually an m for slope. But you will see that even in grade 12, we start to call that a. That's like the leading coefficient. The variable with the highest exponent, whatever that number is, we call that the leading coefficient. Okay? It produces a straight line since the highest power of x is 1. The equation has a degree of 1. Okay? So we do linear a little later again. Okay? But this was, the highest power is 1, so it has a degree of 1. Okay? Note that y is equal to ax plus b can also be written as y equals mx plus b, where m is the slope and the constant b is the y-intercept. Okay, so this is how you learned, because in IPR you didn't go any further, so we just kept it at m, okay, for slope to be specific. A quadratic function has the equation y equals ax squared plus bx plus c. And the only requirement for this, listen carefully, because some students think it always needs to look like that. The only requirement is that a, that leading coefficient, cannot be equal to 0, which is also saying that b or c could be 0. This could be, like, you could have an equation that's just like that, right, where b and c are 0. But anyways, note that b and c may be 0, so I'm telling you that straight up front. Where a is the, you guessed it, leading coefficient, that word coefficient, right? That will come back in grade 12 applied, mark my words. And the constant c in this case is the y-intercept. And y-intercept, last year you may have written it like y-intercept is equal a number. We like to say it's 0 and then whatever c is. Okay, this is a point. Okay, this is a point on the coordinate plane. It's actually a specific point. Okay, it produces a parabola. Okay, since the highest power of x is, you scan it and there's that 2, right? The equation has a degree of 2. Quadratic function will always produce a parabola. Okay, and it points either up or down and expands sideways indefinitely. I also like to see, if you forget parabola, it's a horseshoe, right? Horseshoe, and it either goes like this or it goes like this. That's it. There are no other ways of doing a quadratic. It's either pointing up or it's pointing down. That's it. Sideways, can't do it. That's not going to be a quadratic, okay? So state whether the following graph is one of the following. Is it a constant function, a linear, a quadratic, or not applicable? Okay, so this one would be a quadratic. Because we know it's going up like this. And notice that the tips of the graph, they actually keep on expanding sideways indefinitely. Like it just keeps on getting wider and wider. Okay, this one would be not applicable, because this is kind of telling us that this leg is going further down, so it doesn't give us an indication that it's going to go back up. So not applicable. Okay, this is a quadratic. It points down. And by the way, let's go, degree would be 2. Same with this one. Degree would be 2. So the quadratics we know definitely by looking at the graph, that shape you should recognize that is a quadratic, which means that the highest power of x of the resulting equation would be 2. This is your linear. The degree obviously is 1. Then we have our constant. Do you remember what the equation of this would look like? A straight horizontal line? It's just going to be y is equal a number. You remember? Y is equal to 2. It's going to be a line that goes through y is equal to 2, right? So y is equal to a number is the classic equation for this particular graph, and this is a not applicable. Okay, sideways, it's sideways parabola. Okay, not quadratic. Okay, that's not a quadratic if it's sideways. There's that. What's the degree of a constant? Anybody know? It can't be, you'd be tempted to say 1, but it's actually 0. The degree is 0. Okay? Because it's kind of like saying y is equal to 1 x to the 0, right? And you know that anything to the power of 0 is just 1. Do you know that? I don't believe you, Mr. Rickson. So let's 10,258 to the power of 0. It's just 1. Okay, that's by definition. Okay, so let's do some filling in boxes here. Let's do the degree first. If you look at this one, you should recognize that x has a degree of 1, so that's 1. The second one, x isn't even there, so the degree is 0. It's a horizontal line. It's a constant function. Here, you look at x, right? The highest power of x is 2. The higher power of x here is 3. The higher power of x is a tricky one. I put it in there for a reason. Do you remember if this is really saying 1 over x, right? There's a power of 1 there, but if you were to, what happens if you bring this term up? What happens to the exponent? X to the negative 1. Do you remember when you bring stuff up or down, the sign of the exponent changes? Oh my goodness, don't worry about it. We won't need it other than today, but this would be a negative 1 degree. What about this? What do you think happens? I know you've seen this. If you distribute that, what are you for sure going to have in as part of your distributed outcome? Don't you remember? It's going to be an x squared in there. Watch. This you need to know, right? So let's first go 6, and first let's distribute. X times x is x squared, right? X times 3 is 3x. Then you go negative 5 times x is negative 5x. And negative 5 times 3 is negative 15. We won't even bother simplifying it. you just recognize, right, that there's going to be an x squared there. You don't need to simplify that. You know that's a degree of 2. In fact, when you have brackets and there are two x's, like an x in either one of those brackets, you know for sure it's a quadratic. You know it's a quadratic. So type of function, this would be linear, constant, quadratic. Hold it. Why? Because it has a degree of 2. I know it's a quadratic. What would you call something with an exponent of 3 that comes back in applied 40s? It's a cubic. It's actually a cubic function. Don't worry about it. You won't have to know it this year. But I like to foreshadow. I like to prepare you for next year. This one, not applicable. And this one is a quadratic as well. Okay. What's the leading coefficient? I'm going to use a green highlighter for this one, right? Because the leading coefficient is always in front of the highest power of x. So in this case, it's actually right there. It's just 1. In this case, what's my leading coefficient here? It's actually 0. Because there is no variable, no highest variable of x. So whatever, if it had been there, it would be 0. Okay? In this case, -3. So I'm going to go highlight that -3 here. That's -3. In this case, it's just 1. So what should I do there? I'm just going to do like that, right? It's 1. In this case, we're just going to leave it. In this case, it's, what would it be here in this case? You're tempted to say 1, right? But that 6 is going to multiply that x squared. You end up with 6x squared. Yeah. We're going to go NA here for this one. And the constant is that solo number without any variable attached to it. So the constant here would be 7. The constant here would be 15. The constant on this last one is -5. Okay. The constant here, what is it here for this one? 0, right? There's a 0 as your constant. We're going to go, and this is technically 0 as well. And what's the constant here? It's not going to be 15. If you distribute this out, 6 times 15, that's -75, right? No. 90, sorry, -90. Okay. And you don't need to worry too much about this right now because I will give you some tricks to figure this out, okay? Can I just say that this is just at the bottom of this last column here, that is really the Y-intercept as well. You just figured, like if you know the constant, that constant number, that is actually the Y-intercept of that function. That's where the graph is going to cut through the y-axis. Okay. All right, let's go over to our next page. I feel like that's going to bite me not finishing this one. I feel like some of you are going to look at it and be like, what happened? So can we actually finish it? Sorry. Constant back and forth, eh? Let's clean that up. X squared. What's 3x and -5x? 3 and -5, that's -2x, right? Minus 15. So I combine the like terms in the middle, and then I will distribute. So this would be 6x squared. 6 times -2 is -12x. 6 times -15 is -90. And right then you're going to see, oh, okay, I get where you got the 6 from. I get where you got the -90 from. Otherwise, right, it's not, I think, I don't want you to get confused there. It's just good old distribute and simplify. That's what you would have seen in IPR. Distribute this, then simplify. Okay. Okay, so there are three forms of the quadratic. So at the top of this page, of page 2, something went wrong there, making the first page yellow. I probably tried to insert a cover, and that didn't go so well. Three forms that you need to recognize. General form is the one I already showed you. The second form you will encounter is y is equal to a times x minus h squared plus k. And you see the squared there, right? X is going to ultimately be squared, even in this form. And the last one is the factored form. And here's the good news. Whenever you get an equation, it doesn't matter what it looks like. You can always type it into your calculator and graph it. It doesn't matter how ugly it is, what it looks like, decimals, fractions, you name it, roots, you type that in, and the calculator will allow you to find anything I ask you for. So you don't need to dread the way it looks, but you need to know sometimes what it tells you right off the bat. Okay, so this one, if you get this one, this is what it gives you. It gives the y-intercept right off the bat. And so how do you know it's 0? X is equal to 0 at the y-intercept, right? And that c goes in there. Okay. So that right away, boom, I see that there's a c. It's my y-intercept. What if c is 0? What if c is 0? What would be the y-intercept in that case? 0, 0, which is also known as our origin, right? The center of the Cartesian plane, 0, 0 is the center. So don't let that throw you off. It's the origin and the y-intercept at the same time in this case. This one gives the vertex. And that's why it's called the vertex form as well, descriptive or vertex, because it gives you the vertex. And this is very important to get it right, though. I'm going to use a red pen to emphasize it. Whatever h is, you're going to have to change the sign to it. Okay, whatever h is, you're going to have to change the sign. In math, how we do that is we put a negative in front of it. So if this is positive 2 in there, you're going to have to put a negative 2 in the vertex. And k is here. Okay, k doesn't change signs. And you're probably wondering, Mr. Dirksen, what in the world is a vertex? To be continued. Okay, right now, just trust me. And this one gives the x-intercepts. And it would be like this. You also have to change the sign of it. Negative r, 0, comma, negative s, 0. I'm going to use orange. Okay, so this one is here, and this one is here. And I feel like I need to clarify x and y intercepts because I'm assuming you know, right? But I will give you a quick little visual just at the top here. So if you had a Cartesian plane, right, coordinate plane, and you had a parabola like this, then these two here would be the x-intercepts. This is x-intercept and x-intercept. And you're like, oh, I can have more than one? Yeah, with the parabola, you can have more than one. You can have no x-intercepts, you can have one or two, more to be continued. And this, where it crosses the y-axis, that is what we call the y-intercept. Okay. And there's a certain characteristic, the y-intercept, we know that the x value is always 0, so 0 number. That's how we state it as a coordinate. And the x-intercept, we know that for you to be on the y-axis, that means that y has to be 0. So we know that the first number, there will be some kind of number for this, and the second one will also be number, and y is equal to 0, right? So that's how x and y-intercept are different. Okay. So keep that in mind, that we have x-intercepts and we have y-intercepts. And for x-intercepts, you know the y is 0. For y-intercept, you know that the x is 0 right off the bat, just by hearing those terms. Okay. Let's keep going. Regardless of which one you're given, simply type them into your calculator. And then use second trace to find additional information about the given parabola. Second trace, what is that? Just trust me right now, just follow me. And later on, it will all make sense, okay? Most of the time, you'll be given the equation in general form. We will start the unit by focusing on the general form and then add the other forms gradually, okay? There are some of the properties of the resulting graph that can be extracted by simply looking at the equation. So when it's in general form, we know the direction of opening, for example, just by looking at it. Okay. So the direction of the opening of the parabola can be determined by the sign, here it is, sign of the leading coefficient A. If A is positive, we know the parabola will do this, opens up. Okay. If A is negative, it opens down. Or points down, points up. Okay. Let's see if I can. As you're writing this down, I'm going to try to Desmos, have you heard Desmos? Desmos, does that ring a bell? Desmos? Your teachers may have used it. Yeah, it's an awesome app. So it's free, right? So if I were to type in y is equal to, let me use the letter a here, a x squared. Let's just leave it like that for now. Add slider, sure. So that's your classic parabola. Watch what happens when I slide. Oops, you can't really see that, can you? Let's just press play here and see what happens. Okay. So watch, if A, as soon as A is negative, it points down, and when A is positive, it points up. So negative, positive, we know right away the opening, which way is it going to open, right? And you can also tell what else is affected by A as this is happening. You notice that it gets narrower and then it gets wider, right? So that's another thing that A tells us, the width of the parabola. So let's pause it right there. Oh, pause it. So what do you notice? When A it gets bigger, it gets narrower, right? But as I slide that down, it gets wider and wider and wider until you get to the between 0 and 1 is when it's going to get the widest, right? Same when you go down between 0 and 1, negative 1, it's we consider that wide, and then as soon as you get past negative 1, it gets narrower again, right? So that's something to remember here. Oh, A is equal to 0. It's now a constant, right? See there? It ceases to be a parabola. So, so that's what it does. So the width of the parabola, follow me down here. So in general, the leading coefficient also determines the direction of the opening and the width of the parabola, okay, from end to end. Determine it by simply looking at A, not the sign. So it could be wide. So a parabola could be wide like this. Let's exaggerate, right? And that is when A, the leading coefficient, is between 0 and 1. We consider that a wide parabola. So you want some examples? It could be half, 0.7732, 3/4. It could be negative 0.12, right? Anything that is between 0 and 1. Oh, yeah, I'll leave that negative there. So focus on the value itself, not the sign. The sign we already determined tells us which way it's going to open, but then you focus on the actual number. As soon as it's greater than 1, now it's going to be something else, right? So if A is equal to 1, that's our classic normal parabola. So let's make that somewhat normal. What does normal look like? Like this. Okay. And then narrow, we're going to make a very exaggerated narrow parabola. So it doesn't have to be just there, right? It could be anywhere on the Cartesian plane. This thing can travel, right? And so if A is greater than 1, you have a narrow parabola. So example 1.01, right? 34.75, negative 23.752, negative 1001. So as I'm saying, as I focus on the value itself, not the sign. Just look at it. Almost forget about the sign. It's like, is that bigger than 1 in terms of the value? And yes, right? Is 1001 bigger? Yeah. Is 1.01 bigger than 1? Yeah, it is. Not by much, but it is. Oh, we have to have a fraction in there. 3/2, let's just do a classic. 3/2 is 1.5, would also qualify as bigger than 1. Okay? So two things right off the bat just by looking at it. Hold it, Mr. Dixon. So if I go back to the top, you gave us the 3 forms, right? If I can look at A, then I can make the same conclusion? Yes. As soon as you see A in any one of those forms, you can make this conclusion. Okay. Now we're on white. So now your eyes won't hurt as much. That flickering, I apologize. I would probably have headaches by now. Page 3, but it's better a booklet than no booklet, if you ask me, right? Don't need to write the whole thing now. Okay, Y-intercept, a quadratic function will always have one Y-intercept, okay? One. Always have one Y-intercept. So that is not negotiable, right? Like it has one. When the equation is in general form, the Y-intercept will be 0c because it is the point on the y-axis. Note, very important note, if the equation or a function has brackets, if there are brackets, okay, then you have to use the y-intercept, then you have to find the y-intercept using this. And this right now is not going to mean much to you, but I kind of wrote it like if you review your notes and you've already done everything we have done, then you will know exactly what we mean by that. Okay. So for now, just trust me. Okay. So here we go. Find the fill in the following chart. So I will ask you to fill the rest in. I'll just guide you through one. Opening of this, you look at the sign, right? A is negative, so this will be down. Okay, that you know that this is true, so it'll be down. What's the width of this parabola? Just look at the value. A is greater than 1, therefore it's going to be narrow. Okay, so this is my explanation and this is my conclusion. What's the y-intercept in this case? It's going to be 0, comma. Does this have a C? It's invisible, but it's there. Right? It's 0, 0. Okay, that's the origin. I have to say, what form is this in? Out of the three I just talked about. General. You know how you know though for sure? Are there any brackets on the right hand side? No. So you know it's general. This one looks scary, but has no brackets. That's general. No brackets, general. Anybody in physics? You're gonna see that parabolic motion, like when we throw objects into the air, they follow up parabola. You're kind of gonna see some similarities in physics there. What about this one? It has no brackets. It's still general. Brackets. So all we know right now is this is not general. Sorry, not general. Actually, can I narrow it down to what it is? What do you think this would be? Vertex or factor? Yeah, vertex. That's the only thing. If you have booklets, I sometimes deviate from the plan, so you might have to erase from time to time. So for this one, you're gonna have to use calculator for that particular one. You can't just say 0C for that one. You can't. Okay, it's gonna be wrong. So leave this one for now. Just this one, sorry, this one right here for now you will leave. Try to fill in the rest of this chart on your own. See if you can do it. I think you can. I hear you. So let's check the first table. So again, with this, the leading coefficient is 3.75. That's my focus, right? So I see that A is positive, so it'll be pointing up, right? It'll be pointing up like this. And the width is, what would you say? That would be narrow as well, right? Because A is greater than 1. Just looking at the value itself, not the sign. The y-intercept, this is actually a constant, right? It would be 0, -2. Right? If there is a number on its own, that is your y-intercept. I like to state it as a coordinate, not y is equal to -2. You might have done that in IPR, right? You plugged in 0 for x and then you solved for y. Y is equal to -2. I like it as a coordinate because otherwise we mix it up with a function. Okay. Next we have this in general as well. A is negative, so this will be down. And this will be narrow as well because A is greater than 1. Just at 7.8, right, is bigger than 1. And again, my y-intercept is 0, 9. Okay. And one more. General form. I look at A that's in front of x squared here. So A is negative, so this parabola will be pointing down. A is, you can do this. I just do one of these, right? They're all pointing the same way. So you're saying A is between 0 and 1. So this is a wide parabola. We would consider this a wider parabola. It's 0.5, right? And what's my Y-intercept? Is there a constant there? No. So it's 0. Okay. Vertex form. This is still A, so A is negative. This will be pointing down. This is where A is between 0 and 1. So this would be a wide one. And how do I do that? And I will risk it. I will risk it. We're doing good on time. So grab your calculators. I want you to dive into the world of calculators. And I hope this works. Technically, I need to give you a bit of an intro, but I think it'll work. I think it'll work. I'm fairly confident. So press y equals. Whenever you want to enter an equation, you press y equals, okay? And there should be stuff there because somebody used it before you. So this is what you do. You see that clear button right here on the right side? So go to the first one and just hit clear. And then go arrow down and keep clearing everything. There should be nothing. Sometimes students are sneaky. They want to confuse you, so they sneak one and way at the bottom. So make sure you go all the way to the bottom. And there's nothing there, right? It should be all clear. Okay, go all the way to the top again. And this is important. Watch. You see plot 1, 2, 3 at the top? Is it highlighted? For some of you, it might be. If it is highlighted, like if it looks like this, okay, you need to go all the way to the top and then press enter to deselect. So if it's not selected, don't worry about it, right? So it should not be highlighted. It should not be circled or whatever. Okay, got it? So those are the prerequisites. The next thing I want you to do is, for now, just trust me. You press the zoom button. Yeah, and then we're gonna go standard zoom. You see option number 6? Because you're gonna be able to zoom in and out. And I don't know what students did before you with zooming. So we're gonna go zoom 6, hit enter. And so there's nothing graphed, right? But now we are all looking at the same window. We're all looking at the same thing. Let's go back to y equals now. Seriously, I want to go back to my home screen. How do you do that? Second mode. Second mode quits. Anything you're doing, you're back to the home screen, okay? So you don't need to panic when that happens. Press y equals again, and let's type that in. Let me see the whole calculator. When you have a leading coefficient with a negative, you cannot use this minus. It's going to give you an error. You have to use this negative down here. You see it in brackets? So press negative 0.91, open the brackets, and this is your X button right here. Watch my orange. That's your X button. Don't use times. If you use times, watch what it's going to do. Right? That's not X, right? So you got to use that button. That's your X variable. And what else? Plus 2, right? So plus 2, close brackets, to the power of, I use this little hat button here, 2. Then go arrow sideways because you got to make the cursor come back down to the main floor, right? So I'm going to now zoom into my, oh boy. There you go, there you go. Minus 3. So if there's a, now it's a subtraction, you can actually use the minus button, not the negative. If you use the negative button here, it's going to multiply it, and we don't want that. Do we all have this typed in? No? Yeah. Yeah. Any Anybody have issues typing this in? Let me know, please. Before I graph it, I want to, oh, some of you already graphed it. You can go ahead and press graph. Hit graph at the top right. There's the graph button, right? Right here. Hit graph. See if you see something. Everybody seeing it? If you're not seeing it, you gotta let me know because I can't read your mind. Yeah, I can't read your mind. Everybody seeing it? Okay. Okay, so everybody's good? Yeah? Okay. Phew, it worked. So here you go, guys. I told you just up here what you're going to have to do to find the Y-intercept if it's not in general mode. Can we follow those instructions? So second, press the second button on your calculator. It's a blue one. Let me just zoom out here a bit. The second one here. Second, trace. What you're really accessing is calculate, right? Second, trace. And then we're going to use that first option. Hit enter. What is it asking you here? It's saying, hey, give me an X value and I will find the Y value for you. What is X equal to when we're finding the Y-intercept? 0, right? So type in 0 and then hit enter. You see at the bottom here, it should be negative 6.64, right? So you write that in here, negative 6.64. And we're on page 3. So watch, and the cursor is right there, right? It's telling you exactly where it is. Okay. Let's do a little bit more exploring. What if you go second trace again? Let's try that again. Second trace. Let's do value again. What if the X value I'm interested in is negative 2? Let's type in negative 2. Negative, not minus 2, negative 2. Watch what happens if you go minus 2. Error, syntax. If you're into computer science, syntax is like you typed it in wrong, right? The code is wrong. So you're going to go, what I usually do is go to, and then it will tell you what it doesn't like. It doesn't like that negative. So I'm going to change that to a negative, negative 2. And then it tells me that the Y value is negative 3. So it allows you to find points on that curve. All right, isn't that cool? I find it cool. So there you go. We're going to leave that at this. I'm just going to fill this one in for today. And I'm going to continue my journey and maybe come back to that other one on Monday, Tuesday. Because you're going to probably need a bit of a refresher. So I'll leave that for now, okay, to be continued. Let's go to page 4. Again, I know I'm downloading a lot of information, right? You're a bit like, what? You know what? I'm going to make that table homework. Okay, so write down homework on top of that table. I think you can handle it. And then on Tuesday, we come back and correct it. Let me just focus in a bit. Okay, other properties that can be determined using the calculator are the vertex, the coordinates x, y of the point where the parabola, here this is very important, I can use my yellow highlighter, I'm so happy. The vertex, what is it? Is the point where the parabola changes direction. Okay, that is important. It can be the highest point, which is the maximum, or it could be the lowest point, which in that case would be the minimum. It can't be both. It can only be one or the other. So if you look at your equation and you realize A is positive, you right away, without graphing it, know which way it's going to open. So let's do one of these arrowheads. And don't make it look like a U, okay? A U, then there would be parallel lines. This actually keeps on opening up indefinitely, okay? So the vertex would be right there. It has coordinates x and y, okay? And in this case, you would use this. Second trace. In this case, it's the lowest point, right? Would you agree? The parabola, if you read a book from left to right, correct? Or a sentence. So you would read a parabola from left to right. Start on the left leg here, and you realize that it keeps going down until it reaches that point, and then it changes direction, it goes back up. So this is the lowest point. So we would have to use these buttons on our calculator. Alternatively, if it had been like this, okay, then in this case the vertex is right here, and that's still x, y. And in this case, you would use second trace max. Anytime you want anything from a graph, use second trace. And then you're going to have to select one of those options there. Lowest point, right? And here it's the highest point. And I forgot to put A is negative here. The coordinates of the vertex provides us with two additional pieces of information. So once you find the vertex, okay, there are actually two things that you're also finding when you're doing that, okay? Let me just just scroll down a little bit, okay? So first off is the equation of the axis of symmetry. So the vertex provides us with this, and it also provides us with this. Okay. The equation of the axis of symmetry, it's a vertical line, right? What is the axis of symmetry? It's a vertical line that cuts the parabola in identical halves, and it goes through the vertex, okay? So it's a vertical line that cuts the parabola in halves, and it goes through the vertex, okay? So in this particular case, it would actually be this line right here. I'm going to make it a dashed line because usually it's not part of your graph, okay? You don't have to necessarily include that. So this is your axis of symmetry. We call that the axis of symmetry, but when you want to graph it on here, it would be, let me just, let's label this vertex because you're still new to this. This is the vertex right here. It's talking about this point right here. So this line would be x is equal to, and what does x equal to in this case? It goes through the vertex. X is always equal to 2 in this case. So the axis of symmetry is a vertical line, and vertical lines you always go x is equal to a number. And I will use a different highlighter for the other thing that it tells you. The equation of the max and the min. And it's a horizontal line that goes through the vertex as well. And watch what this does. It's different than the axis of symmetry. It goes horizontally like this. In this case, what is it? The max or the min? Read it from left to right. It's the max, right? So this is the max. And specifically, we will say y is equal to, what is y equal to when it goes through the vertex? It's 3. Right? So the vertex gives us, so once you get the vertex, you also get two things. Can I do this? I think this makes sense to do that and to do this. Right? Like it splits it into two additional pieces of information. And you know what? There's a problem with this graph. There should be arrowheads here. I just couldn't do it with this software. So let's just do that ourselves, okay? Arrowheads, so it's implied that it keeps going. Okay, here, the vertex here is right there. So the axis of symmetry is a vertical line that goes right through your, and so this is the axis of symmetry. And in this case, it would be the line x is equal to, what's x equal to in this case? Negative 2.3. Decimals are fine. Okay, we're not going to fear them. That's just what it is. Okay, and then, so the 2.3 is right there. And our equation of what is this in this case? You can only have a max or a min. You cannot have both. In this case, it's the min, right? It's the equation of the minimum. And that would be a line y is equal to negative 3.5. Can you see that there? I think it's visible. I'm going to highlight that. And I think just to make this abundantly clear, at the top right here, under the axis of symmetry, x is equal to a number. Like that's how you're going to state that. If I ever ask that, that's how you're going to do it. And this is going to be y is equal to a number. And that number is coming from the vertex. Okay, that number comes from the vertex. Sorry. This is the x value of vertex. Okay. I always feel like it doesn't hurt to be overly descriptive, right? But it hurts to just assume that you know y value of vertex. I think that makes more sense, right? Because otherwise, like, well, where's that number coming from, right? It comes from the vertex. I want to do a little bit more. And that's finding the x-intercepts. I might run out of time, but I'm hoping I'll get there. Okay, next page. Okay, x-intercepts. Quadratic functions can have up to, this is the key here, x-intercepts, you can have up to 2 x-intercepts. Right? Notice a pattern for applied 40S. The degree of the function tells you how many x-intercepts are possible. Isn't that cool? So if you had a cubic, which you will see next year, there will be up to 3 x-intercepts, right? And so that's kind of cool. So what I need you to understand, it could have 0, 1, or 2. That is what actually is happening with that little statement. I'm saying up to 2, but it could be that there are none. There's just 1 or 2, okay? So let's explore the 3 instances. No x-intercepts, vertex is above, I'm going to shorten this. Vertex is above x-axis and, right, points up. And that would mean that A is positive. That's our first scenario. And so let's look at it. I'm just going to have the whole thing on here. The other one is where the vertex is below x-axis and points down. So let's do a graph for this scenario. The vertex is above the x-axis and it points up. Assume. Or the vertex is somewhere below the x-axis and it points down. You can clearly tell no go, right? No x-intercepts ever. It's not going to happen. Okay. What's happening there? Oh, the train. Vertex is on the x-axis. And I'll make a note here. The vertex is also, what else? If it's right on the x-axis, what is it also then? X-intercept, right? The x-intercept? The x-intercept. So, right on the, right, this is my vertex. That's where the parabola changes direction. So I just kind of go off of there. So this would be A positive, right? What if it's somewhere along here and it's pointing down? Does it matter? You still only have one x-intercept, regardless of which way it's pointing. So A doesn't matter. Sine of A irrelevant. Okay, so that's your one x-intercept. Two x-intercepts. Vertex is below. And points up, or vertex above x-axis and points down. So A is negative here, A is positive over there. So notice if the vertex is below the x-axis, excuse the interruption. Oh, that's okay. There and there. Hold on. I would like to. What's going on? How many x-intercepts? 2 for each, right?
scientific announcement